Hi, everyone. In this video, I would like to talk about section 12.1, which is all about three-dimensional coordinate systems. So we're going to be plotting points in a three-dimensional coordinate system. We're going to be using the distance formula. There's going to be a 3D version of that. We're going to recognize the equation of a sphere, and we're going to find its radius and center. And we're going to graph an equation. We're going to graph a few different kinds of equations, including the kind that has a free variable, which you'll find out what that is. So first, I want to recall a few things about two-dimensional space. So first, we assign the origin, and we assign two directions, x and y. Now, the angle between these should be 90 degrees, and the positive y direction should be anti-clockwise from the positive x direction. Now, if you start at the origin and you move only in the x direction, then you'll be somewhere on the x-axis. On the other hand, if you move only in the y direction from the origin, then you'll be somewhere on the y-axis. Now, an ordered pair of coordinates refers to moving a certain amount in the x direction and a certain amount in the y direction. Now, you can make the movements in the opposite order, and you'll still end up in the same place. Now, each ordered pair indicates exactly one point in the plane, and each point has exactly one ordered pair. So there's no point that can't be indicated by an ordered pair, and there's no pair of real numbers like this that can't indicate a point. On the other hand, there's no 2 points indicated by the same ordered pair, and there's no 2 different ordered pairs indicating the same point. Now, here is a picture of what the axes might look like in three-dimensional space, and I'm clicking and I'm rotating it about. Let's see, you're able to see this, hopefully. Had trouble on that front earlier, but I think you're probably able to see this. Okay, yes, so that is that. Okay, great. So we have the origin, we have three directions. You will notice that any two of these axes make a right angle with each other. So if you turn any one of the axes directly toward us or directly away from us, you'll see that the other two make a right angle. Now, the right-hand rule I'm going to talk about on the next slide. So what the right-hand rule is you if you take the if you start by looking just in the xy plane, you notice that the direction of these arrows is exactly the direction. So, okay, before I do anything else, I want to make a note that, that's not quite what I had in mind. Okay. So the positive y direction is what I'm now rotating to be toward the top of the screen. And so you will notice that the direction of these arrows is the same direction that would be the positive rotational direction on the unit circle. So if you rotate the fingers, all the fingers other than the thumb, on your right hand in that direction, then the direction your thumb points will be the z direction. So that's why we call it the right-hand rule, is because you do that specifically with your right hand. Now, if we want to draw a location in three-dimensional coordinates, specifically draw a point, well, here is a picture of how that will look. So in all three dimensions, it can look something like this, and I'm rotating the direction a bunch, but one thing I want to point out is that no matter what angle we look at things from, the segment that's parallel to the z-axis will remain parallel to it no matter what angle. And same thing with this one, which is parallel to the y-axis, and this one, which is parallel to the x-axis. So when you're drawing a diagram yourself, keep that kind of thing in mind. Okay, now how can we draw a diagram of this other point here, -5, 1, and -4? Well, here's how this could look, and I will again click it around and rotate it. I've got a few other example videos I've already made where, well, I was gonna make them after this one, but this one I had trouble with the first time around. So here we go. As you see, again, x parallel to x, y parallel, and z parallel. And two lines that are parallel will look parallel no matter what angle you look at them from. So keep that in mind for your own drawings. I have another video where I've worked this exercise. Now, the distance formula in three-dimensional space. So we have, first of all, if we were just in the xy plane, then we have the distance in the x direction and the distance in the y direction. Then the overall distance from the origin to this other point here, that's going to be the square root of x squared plus y squared according to the Pythagorean theorem. Now, if we instead bring things into the third dimension, then one of the legs of this other triangle here is now the root of x squared plus y squared, and the other is z. Apply the Pythagorean theorem to that, we get the root of x squared plus y squared plus z squared. So that is the distance from the origin to any given point x, y, z. More generally, the distance between any 2 points, x1, y1, z1, and x2, y2, z2, is this. Now, just as a quick reminder, the graph of an equation is the set of points whose coordinates make the equation true. So we want so each point is given by an ordered triple, and if an equation has x, y, and z in it, then we make the appropriate replacements from the ordered triple, and we see if the equation is true or not. And if the equation is true, then the point is on the graph. Now, this expression that you see here is effectively saying that the distance from x, y, z to 0, 4, and -1 is 3. It's a 9 over here because there's no square root on the left, but this is the sphere of radius 3 centered at the point 0, 4, and -1. That's the definition of a sphere, just like would be for a circle in 2 dimensions. It's the set of all points with a specific distance from a specific point. In this case, that point is this point here, and the distance is 3. So here's a 3D thing that lets us rotate it around at least somewhat, and I'm gonna go ahead and zoom out. Okay, yeah. So being a sphere, it's gonna look roughly the same from pretty much any direction, but I hope it's clear to you why this is a sphere. And sorry, I didn't mean to move that point around, so ignore that. Okay, I have another video where I worked out this example. I now want to say a little bit about coordinate planes. Graph of z equals 0 is the xy plane. That's the one you see in gray here. Graph of x equals 0 is the yz plane. That's the one you see in blue. And the graph of y equals 0 is the xz plane. That's the one you see in yellow. Now, so in this case, the xy plane and the z-axis are both gray. The yz plane and the x-axis are both blue, and then the xz plane and the y-axis are both yellow. Now, suppose we want to sketch a graph of an equation like this. Well, it almost looks like what we would expect it to if it were y equals x squared minus 3 in just the xy plane. It would look like this thing here on the left. Now, as for if we were to replace this y-axis with a z-axis and this letter y with a letter z, then that would look the same. But since we're actually in 3 dimensions, what that means is that y is allowed to be anything at once. And so any point that's on this graph, if you just change the value of y, the new point will still be on the graph. So let me just do a little bit of rotating here. Okay. So if you look just from the if you look just from the, say, the positive y direction, now we have the positive x direction going to the left, but we still have this parabola. On the other hand, if we rotate it 180 and we're looking from the negative y direction, now again, it's we have the same parabola as we do on the left side of the screen. But of course, rotating it any other way, we are going to have yeah, rotating it any other way, we are going to we see that it's a surface, and of course it extends infinitely in this. It extends infinitely as you go up this way or up this way. Sorry, up this way, and it also extends infinitely if you follow the y direction. You can allow y to be anything at once when x and z are not changing. I have another video where I worked these out. And here are some summary questions. First, what is the right-hand rule and what does it tell you about a three-dimensional coordinate system? Second, in 3-space, what is the y-axis and what are the coordinates of a general point on the y-axis? What is the xz plane and what are the coordinates of a general point on the xz plane and what's the equation of it? How do we use a free variable to sketch a graph, and how do we recognize the equation of a sphere? That's all. Thank you for watching.